Around the world, there are factories making everything from bikes to biscuits, with mega machines mass producing and highly skilled workers handcrafting. They are the products we use every day. But have you ever wondered how these boots were made for walking? A century-scoring cricket bat was crafted? Or what keeps a watch ticking? Well, sit back as we go behind the scenes on The Production Line. Wagon wheels are the big guns of the biscuit world. Recently celebrating their 70th birthday, they rolled into town when the Wild West ruled the silver screen. And the mighty wagon wheel has been cleaning up ever since. A wagon wheel is marshmallow and in some cases jam sandwiched between biscuit and coated in chocolate. Almost 280 million are devoured around the world every year, from Russia to Australia. As you can imagine, satisfying our appetite for these marshmallow-filled treats is no mean feat. Nearly 1,000 wagon wheels a minute fly off the production line, 24 hours a day, 5 days a week. The wagon wheel journey starts here, in the flower loft. And it's a journey that Steve Norris has been watching for over 35 years.
So this is the area of what we call the flower loft. This is where all your bulk ingredients from your main silos outside feed through to the mixers.
Keeping the shelves stocked with wagon wheels requires 100 tons of flour and 15 tons of sugar each week. And the dry mixture in the flour loft needs to get oily and fatty. 384 kilos of it are sent downstairs to the continuous mixer to be blended with 94 kilos of oil, water and glucose.
So at this point, what is crucial is to make sure that temperature is right and all the ingredients are right. If we don't get it right there, we cannot process it down the line. And on the exit of that mixture, you can then see we produce dough.
The fresh dough heads from the mixing room to the machine shop to be rolled out and cut into biscuits. It's then spread out across a web conveyor.
The web, we're spreading the dough out equally across the web to make sure that we fill the hopper correctly. If we don't fill the hopper correctly, we'll then have patchy biscuits.
Patchy biscuits? We wouldn't want that, Steve. The hopper drops the dough onto a series of rollers. This giant brass roller weighs around 350 kilos and cuts out 96 biscuits with every turn.
We'll fill the hopper to a certain level. We're then forcing that dough with the back roller into the moulding roller, producing the approximately 2,000 a minute.
It's not so different to baking at home. Once the dough has been rolled out and cut into shape, it's time to pop it in the oven. Although this oven is probably a little bit bigger than the one in your kitchen. It's nearly 100 meters long. And a conveyor belt means the biscuits are always on the move.
This is a 3-zone oven. So the first zone gets all your ingredients going. The second zone, bake it. And your last zone, your third zone, give you your colour.
It's all very high-tech. Cameras are constantly feeding vital information to the biscuit boffins in the control room.
There's 8 screens in total. You've got 6 screens giving us data back, and you've got 2 screens of CCTV. And that data on the top screen is showing you the ovality of the biscuit, the length of the biscuit, the colour of the biscuit, the moisture.
Once the biscuits are baked, they need to be cooled. Putting mallow onto a piping hot biscuit would make a real gooey mess. Of course, this biscuit wouldn't be the legendary wagon wheel without a soft marshmallow centre. Marshmallows were once made from the sap of the marshmallow plant. Nowadays, they blend gelatine with 80-degree water and glucose to create a syrup. By beating air into the syrup, you create a fluffy mallow mix. But to do that, you need a Mondo mixer.
So basically, in this machine, our Mondo mixer is the Mondo head. We've got chilling pipes coming in to keep it cool, but that rotates to something like 950 RPM. We control the speed of that to allow more air in or take more air out. It's a bit like making meringue in the kitchen kind of thing. So this is a sample of the syrup prior to the Mondo. And when we aerate it, and that's the result of it.
Burton's have a rather clever V-belt system that allows the biscuits to bottleneck here without being damaged. Then they're spread out into position, ready to be covered in the lovely fluffy mallow. And today, we're making jammy ones.
We were constantly monitoring the biscuits, the shapes, how thick they are, and then we're monitoring the mallow, and we're constantly watching the jam, the temperatures. So, it's hands-on all the time. On a good day, we just have a really consistent run, whereas we can have lots of problems, especially during the summertime, where the temperature is a lot higher, so the chocolate takes time to set.
Thankfully, that's not proving to be a problem today.
We're now depositing the mallow, and in this instance, jam, onto the biscuit. So when that manifold opens, it opens twice. It opens to allow some mallow, and then it opens to put jam, then mallow again.
Wait a minute, that's 3 times.
So it's one operation, but it's like 3 stages.
Here's a biscuit with a jam inside. Obviously, if we open it up, you can see that the jam is engulfed by the mallow. But then obviously when we dig in, the jam is actually inside.
This complicated machinery needs constant supervision.
Yeah, we do poke a lot of biscuits with sticks.
We then transfer into the enrober.
Nearly 50,000 biscuits an hour move through this machine.
So basically we are coating the old product with chocolate.
The chocolate is heated in a kettle to a precise temperature before being pumped into a machine called the enrober.
So once it comes through this process here, we then got 2 blowers. We've then got licking rollers. We're now removing the chocolate off the bottom, so there's thick chocolate on there, to achieve our target weight.
Chocolate is quite pricey, and making wagon wheels requires 50 tons a week. But thankfully, none of it is wasted. The system returns the chocolate that isn't used back to the kettle within 2 minutes to be reheated and pumped through the enrober again.
So it's taken 12 minutes to there. We're now into the chocolate cooler, 7 minutes to pack in.
Okay, so the wagon wheels are ready for the best stage of the whole process, eating. They just need to be wrapped and packaged.
We've just come out of the chocolate cooler, and we're now splitting off. We've got 4 legs into the packing hole, 4 lanes per wrapping machine.
And it seems that heavy lifting can even make clever machines temperamental.
The guys working on the V-belt, they're looking at the mallow hanging out, full coverage of chocolate, big feet on them. They're looking at the product quality.
The biscuits are wrapped individually and then packaged into 6s, or, for the shops with the hungriest customers, 8s.
So we've now moved from the packing area to the case packing area. You can see the one arms are collating the product together, then the robot arm, the vacuum arm, then transfers it from the collating into the case itself.
Quality control is incredibly important.
Obviously, the line's very big out there, and we produce massive volume. So by doing the hourly checks, at least if you do find an issue, you can actually hold that within an hour and maybe get it right then for the next hour. I think it's good sometimes to eat your products. It's nice to actually see them in store as well. The first thing I do when I go into any supermarket is go and look at our products on the shelf, just to make sure everything's good as well. You just can't help it.
To satisfy our craving for wagon wheels, the factory produces a whopping 23 million every month.
As you can see, we've transferred the product now within our case. So this is our wagon wheel journey, the end. This now goes onto a pallet and goes to our customers.
There's 26 pallets on a lorry, and there are 16 lorries full of wagon wheels leaving the factory every week, destined for biscuit lovers all over the world. The classic Dr. Martens 1460 boot is iconic. Popular with everyone from the police to punk rockers. They launched in 1960, selling for £2 a pair, but nobody could have predicted how they'd kick on from there. And marketing manager Dan follows every footstep.
I don't think anybody could have really charted the impact that this boot brand would have had on the world. This is the kind of highlight of the room for me. This is original Joe Strummer archive material. The Clash were synonymous with Dr. Martens. Being adopted by these subcultures, by these youth cultures, I guess it is a phenomenon, really. So it's a really lucky position to be in as a brand.
Doc Martens have factories all over the world, but it's this one where the boots were born nearly 60 years ago. This is where the magic happens. And the man with the spring in his step is manager Stephen Bent.
Welcome to Cobbs Lane. This is where we've been making Dr. Martens for the last 58 years, so our original boots and shoes have been made on this site ever since the brand began. So this is one of our original clocking in machines. A shift worker would have come in, punched their card at the start of the shift, and gone in to do a day's work in the factory.
There are 48 people beavering away here on the factory floor, knocking out 2,000 pairs of boots and shoes a week. Their best-known boot is the classic 1460. It takes just 53 minutes for the team to make a pair.
Within the shoemaking community, we do have our own language, which we refer to as cobblers, and each bit of the boot and shoe has its own weird cobblery name. So we refer to the toes of a shoe as a vamp. If you ever heard the word revamp, that basically means taking a scuffed toe and replacing the leather. The sides of the boots are known as quarters, and there's 2 in a boot, therefore there's 4 in a pair. The tongue in a shoe is called a tongue because you feed your foot into the throat. We say there are 7 key components in a 1460 that make up the brand's DNA, and when we're talking about those things, we're talking about things like the heel loop, we're talking about the 8 eyelet silhouette, we're talking about Puritan stitch, we're talking about yellow stitching through the welt, we're talking about the lines in the side, and we're talking about that tread pattern on the bottom, which we call the DMS sole. The most expensive component in any shoe is the leather, and it's also the bit that people get really excited about.
And Doc Martens get their leather from tanneries like this one. CF Steads have been producing leather for over a century. And amazingly, Doug Crack has worked here for nearly half that time. Animal hides are turned into leather by introducing a tanning agent, which is a chromium-based chemical compound that alters the protein structure of the hide and stops it from rotting. Modern tanning compounds turn the hides a blue colour.
So we're actually measuring the area of the leather and the thickness.
Once the hides have been sorted by size, they're cut and shaved to achieve a uniform thickness.
We actually put it through a Banijay splitter, which is home to a very sharp edge, and split some of the thickness off. And then after that, you shade them here on the shaving machines. It's actually gauging, 1.8.
With the cut and shave complete, they go to the dye house. Doug's son Mike keeps a careful eye on the hides, refining them to suit each customer's needs.
So this is where we start adding characteristics back into the leather by chemically modifying the material to its end use. The chemicals go direct into the drum. It's almost like a washing machine cycle.
The tannery produces leather for a variety of products, from boots to bags to belts. For boots, it needs to be durable and hold its form, supple but not too soft.
One of the things that we have to check is colour penetration, and we'll take out a skin and check it at various points. Obviously, our customers want fully penetrated leather.
Once the leather is treated and dyed, the drums can be emptied. This drum contains 600 hides and 2,500 litres of water. The dye and chemicals are rinsed off, and Doug's team re-wet the leather, horsing it carefully so it doesn't crease. The wet leather is then passed through a tunnel dryer, reducing the moisture content to around 14% before being conditioned in a giant drum.
I mean, when you see the final product, it makes one very proud.
Steads produce a whopping 500,000 square feet of leather a month. That's about 30,000 hides. And many of them end up in the Dr. Martens factory. Now they've got the leather, let's make a boot.
OK, there are 4 disciplines in a shoe factory, and they've all got strange cobblery names. So we've got clicking, closing, lasting, and the shoe room.
The first stage, clicking, means cutting the leather into the required shapes and sizes using a pattern.
Tony's clicker, and what he's doing is he's laying his knives up on the hide and cutting out the bits that we need in the right sequence. And the idea is that the minimum amount of leather goes to waste. Now, the name clicking is actually old cobbler talk, and actually comes from when we used to cut by hand. So when we used to trace around the patterns and come off, just the little clicking noise of the knife is how the room got its name.
The various pieces of leather needed to make the boot have been cut. And for the next stage of production, closing, everyone's sitting comfortably.
So Gail here is skiving off, thinning the edges of leather, ready to stitch. It's become associated with being lazy because in an old-fashioned shoe factory, you'd have to sit down to operate this machine, where every process before it would have been a stand-up process. So if the boss asks, "Where's Steve?" and someone says he's skiving off, it could mean he's thinning the edge of the leather, or it could mean he's just having a sit down.
Gail might be skiving, but she's certainly not slacking.
In a day, I could do 180 pairs.
And there's a very simple explanation for Gail's productiveness,
It's just skill.
even if she says so herself. There are lots of processes in closing as the team stitch together the various pieces of leather to form the upper part of the boot, imaginatively titled The Upper.
This is Lizzie, better known as Queenie, and what she's doing is she's putting the Puritan stitch in, which joins the vamp to the quarters. It's one of the things that give Doc Martens its hard-wearing reputation. Have you ever heard the phrase as tough as old boots? It comes from the fact that old boots used to all be stitched together with Puritan stitching.
It is a Puritan machine and it does like a chain stitch. So therefore it's really strong and well made.
So we've finished in room 1 and 2, and now we're into lasting. The objective in here is to make the upper take the shape of the last.
For those that don't speak cobblers, shoemakers use a pair of foot-shaped pieces of plastic called lasts to mould the leather over and give boots and shoes their unique shape. This machine uses hot and cold moulds to manipulate the leather.
You want to take it from the hot point to get it to the cold as soon as possible because that sets a better shape. I always think about it as a bit of a dance machine because you're operating your foot pedals and your hands and the coordination, but it's all about getting your timings between your hot moulds and your cold moulds.
So in the old days, lasts used to be made out of wood, and you hear an awful lot of talking in shoe factory about whether you can knock on wood. That's basically us asking whether the pattern fits really nicely. Is everything going okay? Knock on wood, it's all right. This is Dino. Dino's toe lasting for us, and what he's making is the vintage 1460 boot. So called because we started making them on the 1st of April 1960. So if you write that down, 1460, that's our signature style. The toe laster's quite a complicated machine, so Dino's going to get this leather to take the shape of this last using all the claws and pincers and pulling that happens inside the toe laster.
The leather upper is held by glue and staples to the insole. That's the bit your foot rests on. But that's only a temporary fix.
Once that's in, the yellow thread is actually going to be doing all of the heavy lifting. So we don't remove the staples on the finished shoe, but they are relieved of any obligation. We've pulled everything in tight, and the uppers are the shape they're going to be. Now we're nice and tight down to the wood. We can knock all the way round because the whole boot is the correct shape. This is where things get exclusively Dr. Martens. We're going to add PVC welt using our yellow thread. So this long strip of PVC here is the welt.
First, the welt is attached to the upper part of the boot. This machine uses yellow thread to stitch the welt to the upper. Now it's time for the sole to be attached. Doc Martens makes their own here in Wollaston using polyvinyl chloride, better known as PVC. The PVC pellets are melted and injected into the mould to form soles.
When it opens up, there should be a pair of soles in there ready for us to use.
The soles are checked for defects before being transported to the main factory floor. Because the welt is made from the same material as the sole, PVC, these can be fused together. No other boot is made this way.
Melting a PVC welt to a PVC sole with a honeycomb shape inside is what Funk and Mertens invented all those years ago.
So how did this revolutionary new way of making boots come about? Well, the story starts in post-war Germany. Dr. Klaus Martens broke his foot while skiing. His boots proved too uncomfortable, so he invented footwear with air-cushioned or bouncing soles by trapping the air inside 2 layers of plastic. Dr. Martens and his friend Dr. Funk formed a shoemaking company. They tossed a coin to decide who to name it after, and guess who won? Yes, Dr. Martens. And production began in 1947. Once the air cushion soles have cooled, they're tacked onto the welt before being passed to Will.
So the process is basically sandwiching that red hot blade in between the welt and the sole, seals it together, and then you've got Doc Marten basically. It can get up to around about 700 degrees. It can be a bit scary. It's all about the handling and the shape of the shoe as you send it around, basically.
We're melting the PVC so they become liquid temporarily, and as they're squeezed together, they'll cool as one unit of PVC.
Essentially, it's one sole unit now.
These little pockets inside that we refer to as the lattice or the honeycomb, that gets sealed up on the heat sealer here, and then when it cools down, you see the smoke escaping, leaving little pockets of air. The concept of this back in the 40s was absolutely revolutionary, but it wasn't really industrialised until it came over to Wollaston and was made here in 1960.
So how did this radical German design end up in England? The Griggs family founded this shoe factory back in 1901. In the late 50s, Bill Griggs noticed an advert for the German-made air cushion sole in a trade magazine. He licensed their product, made a few key changes and branded the boots Airwear, complete with bouncing soles. The name was anglicised and the iconic Dr. Martens boot was born.
Chris is using a 9-arm cutter with a 2-tone edge in it to take our sealed soles and put the required lines in the side that are going to hide the join between the PVC welt and the sole. It looks like it's always been one moulded unit. When the last is removed from a product, only then does it become a boot or a shoe. So we refer to everything beyond this section as the shoe room. It's the shoe room that's taken the product out of lasting and they're finishing it off by cleaning it, by lacing it, by hanging the tags on it, by doing all the preparation that they need to do to get the product to look ready for a customer. Then it's going to go in the box, it's going to get wrapped up. The next person to see it is going to be their new owners.
Dr. Martens have made over 2.2 million pairs of black 1460s over the last 10 years, proving their boots really are made for walking. The cricket bat, famously made from the wood of the willow tree and built to withstand incredible forces. At the top level of the game, batsmen are facing balls delivered at 90 miles an hour. When the bat connects with the ball, 8,800 newtons of force cause it to change direction in a millisecond. That's enough force to lift a small car. So how do you turn a lump of wood into a piece of performance equipment? Here in Robertsbridge, they've had plenty of practice.
This village is where they make them, and they've been doing so ever since 1876, for famous players all over the world.
Thankfully, today's bat makers lose fewer fingers.
When the face of the bat has been shaped and cleaned up, it's put in this press.
And are considerably funnier.
So you see, the bat's face needs just as much care and attention as the girlfriend's does.
Gray Nichols are a 5th generation of family business that grows and harvests all of its willow in-house, well, in the woods. They plant 3,000 willow saplings at over 100 sites every year. Alex has worked for the company for nearly a decade. He knows his willow rather well.
As long as I can't touch my fingers together, we're at about the size we want. So this has probably been in the ground around 18 to 20 years, gradually soaking up some moisture and growing up to a nice size. Should get some good bats out of it.
Gray Nichols have factories in Australia and Asia, but all of their willow comes from the UK and passes through the sawmill.
So once the trees have been brought in, they're then cut to length, 29-inch lengths. We roll them under the splitter and we split them open.
Now, unlike cobblers, bat makers are less cryptic when it comes to naming things. Round tree butts, called rounds, are rolled onto the splitter and split into splits.
So now that we've opened up this timber, we can see this has got a nice, straight, clean grain structure. That's pretty good. The colour in the red, that's just all from the core of the tree. So when it's made into cricket bats, there will be some redwood. But generally, these are pretty good-looking pieces of timber.
Alex hopes to get 8 cricket bats from one round. The splits are passed through 3 saws to be cut to the correct dimensions.
So this is saw number 1. What we're going to do is we're going to put the piece of timber in. We're going to cut straight through the high point on it, giving us 2 blades out of the 1 piece, helping us to increase the yield of bats we get from each tree. On to saw number 2. We're going to cut 2 nice parallel edges on there to give it the edge of the blade. And once it's been through here, we move on to saw number 3. And what's going to happen is it's going to rest on an angle about 45 degrees and be passed through, putting the point on the blade at the back to give you your finished product.
Once the splits have been rough sawn, they become clefts. Each cleft needs to be dried out to remove some of the moisture. After that, they need to be graded.
So what we're first of all looking at is grains, knots, blemishes and stains. Then you're looking at weight. You'll get some timber that's naturally much lighter in weight than others, and that's what we're after, especially when you're looking for bats for your international players. So this here is an absolutely cracking grade 1. Now, grade 4, to put in context, as you can see, you've got a big stain running through it, knots into the potential hitting zone here, and you can have some, we sort of pleasantly call them ugly belters. They're not great to look at, but they hit really nicely. But for a lot of people, it's how it looks will determine how it performs.
There are currently a staggering 100,000 clefts stacked up in the warehouse. Many will be shipped to their international factories, but some of the high-grade timber is turned into bats on site. Once the cleft has dried out, it goes into the workshop. The bat maker decides which side is prettiest, and that becomes the face of the bat.
Now that we can see the grain on the surface, you want to try and get the best possible point in the strike zone. So what we're going to do is we're going to fit the handle to this end. We're going to make this nice whitewood area here the strike point.
Alex makes the top and tail cuts, removing weight at the bottom and making a V-shaped incision for the handle. In the early years of the game, cricket bats were all one piece of solid willow. But as bowling speeds increased, so did the number of broken bats. In the 1830s, bat makers started to splice willow handles into the blades, so they could flex to absorb the shock of the striking ball.
Oh, lovely shot. That was a beautiful off-drive, which would sting his hands, but for a rubber shock absorber in the handle of the bat. Fascinating, isn't it?
Bowling just got faster, and bat making evolved. Rubber-infused cane handles were first introduced in 1853, giving batsmen the much-needed shock absorber they use today. In the modern game, balls are being delivered at 90 miles an hour, so you need even more rubber in your handle. Modern handles are made from 12 laminated pieces of cane, with 3 rubber springs as opposed to 1.
If you're, say, Alistair Cook and you're facing up to Dale Steyn and you dig out a Yorker, that's an impact speed of about 140 miles an hour. You need somewhere for that energy to go, and that's why you have this. It stops your hands, your fingers and your wrists from being broken by a cricket ball.
With the handle glued firmly in place, it's beginning to look a lot like a cricket bat. But unlike these fine young men, it's still a little rough around the edges. Chris is responsible for shaping and pressing the blade, making sure the balance is just right.
This one's going to be a bespoke bat, so it's aimed at a particular customer, so it's all to do with how they play the game and also the preferred weight and balance of the way they play. And that can vary around the world for different surfaces and different sort of skills. So all I'm going to do now is I'm going to kind of trim up a few of the extra bits that we don't need and shape a bit of the back of the blade.
Chris selects a particular profile and draws on it with a pencil. This acts as a guide as he starts shaving down the timber. Chris needs to keep the bat within the dimensions stipulated by the Marylebone Cricket Club, the guardians of the game.
Most of the tools are very traditional. The draw knife is probably the quintessential bat maker's tool. The bat makers with their draw knives are very much like batsmen and their bats. We all have our own little sort of sizes and weights and things, and this is from 1938. There's a belief in some of the carpentry trades that tool steel after the Second World War really dropped in quality. So you'll find a lot of guys searching out for old tools.
Bat makers have been using the same tools and techniques they've been using for years. The only thing that's changed is the dress code.
The back of the bat is now due for still more attention. Very highly skilled work indeed. What fun this man must have given grown-ups and boys alike. Some would say his life is to be envied.
Do you know, I couldn't agree more. It wasn't long before Chris's skills gained him his first big commission. Legendary West Indian cricketer Shivnarine Chanderpaul paid a visit to the workshop, found a piece of willow he liked and asked Chris to make him a bat.
I'd never made a cricket bat for a pro, so I was a little bit nervous, and I was hoping John would do it for me. And John goes, well, he asked you, and Shiv used that against England, and I was lucky enough to see some of it at the ground.
John has racked up his half-century. He's been at the company for 56 years. He's made so many bats, he stopped keeping score at 275,000. John also holds the record for bats shaped in a day. 150 is what cricketers call a daddy century. But he's got no plans to retire hurt.
Retire? What's that? No, I'm just going to carry on as long as possible and probably bury me under the floor here.
Many of John's bats, however, have finished their work, resting in the company museum after seeing action on the international stage.
So we've got bats from all sorts of players, really. There's Andrew Strauss, Laura Marsh, the England women's team player, David Gower, and in the back row in some of these glass cabinets are some of the really old bats, going right back to the 1800s.
Once the bat has been roughly shaped, Chris needs to compress its face to create a hard shell. This is the tricky bit.
This machine, when we're at full extension, is going to be putting about 3 tons per square inch onto the bat face, which is quite a lot for a piece of wood. Most of the pressure is focused in what will become the sweet spot. Normally what you find is to get the highest performance out of a cricket bat, you're getting right to the edge of breaking it.
Willow is much more like a reed than it is a wood. It's that cellular structure inside, and when you compress that face, you end up with a really hard core on the outside, on the surface, and a nice soft spongy core underneath it.
And it's that gives the cricket bat its familiar ping and that lovely kind of bounce. So now it is really a performance piece of equipment rather than just a lump of willow.
Chris continues to plane down the bat, getting closer and closer to the required weight and shape.
Once you start getting to the basic profile, you start kind of picking it up in the hand like this to feel how it balances in the hand. And really then the shaping is all about putting the weight in the right place. In Australia, where the ball picks up high, bounces high, they might go to have the weight higher in the blade because that's where they're going to be contacting the blade a bit higher because it bounces up. Somewhere skiddy, like a lot of the British pitches, you'll probably go to have the weight a bit lower because it's not going to lift as high and you're more likely going to hit the ball lower down in the blade.
The bat has been shaped, sanded and buffed. All that's left are the stickers, and it's ready to knock one out of the park. When you buy a bat, you're paying for the quality of the willow. Bat makers put the same love, care and attention into each one. You can buy a good quality cricket bat for under 100 quid. But their best bat, the Legend, costs almost £1,000.
The Legend is made from the top 1% of willow that we grow. So these are really beautiful bats. Not only does it have to be pristine cosmetically, it has to have the highest performance we can get out of a piece of willow. If you were to buy one of these and played cricket with it, you'd have the season of your life. These are almost too good to give to the pros. And what the pros tend to use would be something more like this. This is actually called a Pro Performance, and it's designed to really be used on the world stage.
That'll set you back around £600, but you get what you pay for. And a test batsman needs the very best.
So if I'm making a bat for a world-class batsman, Shivnarine Chanderpaul, his bats are 2 pounds, 8.5 ounces. He has at least 13 grain across the face. The blade is 1/4 inch longer than standard. The handle's 1 inch shorter than standard. The weight for his bat is right down in the bottom of the blade, and he also likes a redwood edge on his bats. And it's done him pretty well. He's one of the great test batsmen of all time. In comparison, somebody like Alistair Cook pretty much takes a bat straight off the shelf. As long as it's the right weight, which is about 2 pounds 10, and it goes well, he's happy.
And that's cricket, born amongst the shepherds in the Kentish Wealds and developed in the fields of Sussex, where even today, as we've seen, willows are still felled, and master craftsmen shape the bats as in days gone by.
The mechanical watch, and not just any watch, a Bremont. Used by explorers, adventurers, sailors and pilots, these watches are built to withstand the most challenging conditions. Each timepiece contains over 300 tiny components, machined with incredible precision. Behind these doors, a young team painstakingly assemble each of these mechanical marvels by hand. Bremont was set up by two brothers, Nick and Giles English, in 2002. Success has come quickly. They're now among the top 10 chronometer manufacturers in the world.
We're lucky because it's almost like the industry is waiting for a British brand. There are something like 700 odd Swiss watch brands out there. We were one of the very few British watch brands. It really enabled us to stand out from the crowd a little. Having a brother who's got the same interests, especially when you're co-designing stuff, and you have the same sort of long-term aspirations, is very important.
Funny enough, coming up with the sort of type of watches we wanted to produce in the first place is probably the easiest decision because we had a joint love of a certain type of watch.
Aviation style, the traditional British sort of understated look. As a designer, you're looking for inspiration the whole time. I think there's a fuel gauge in an aircraft too, an old car dial.
You just end up using some of your own interests when you're coming up with a range, actually.
These watches retail from around £3,000. But when you see the work that's involved, you'll understand why.
Every watch made by Bremont is made in the UK, and the majority are made in this workshop here. Each watchmaker will be given the responsibility to make X number of watches over a set period of time. So there's a lot of love, care and attention goes into that particular timepiece.
Bremont only make auto watches as opposed to battery operated. And it all starts with the barrel. Each watch has a 400mm long spring, which is tightly wound inside. The force of the spring unwinding and the wearer's natural movement powers the watch.
As this main spring's fully wound inside this barrel, it causes the barrel to turn, and as the barrel turns, it then goes through your train.
The wheel train receives energy from the barrel and causes the hands to turn. Stuart adds the barrel and the wheel train, the first of many components that need to sit perfectly within the watch case for everything to work. Bremont machine all of the parts for their watches, including bezels, which holds the glass face in place, using state-of-the-art computer-controlled machines.
This is our machine shop, and this is solid 316L stainless steel, and we'll machine the tops of our bezels and our cases out of this. Stainless steel invented in Sheffield, so I'm very proud to be working with. It's a perfect material to use for your cases. It's a big machine making something which isn't that big. And every sort of 10 cases or so, you're having to change the drill bits because it wears through, because it's so hard, the steel.
Once the steel case and bezel have been machined, they're cleaned and hand-polished.
It's an incredibly skilled process to be able to do, to get lovely smooth edges on your cases. It's about doing the least amount of polishing, but getting the most beautiful effect. These boys make it look very simple, but it's really not.
Manufacturing parts and assembling watches in-house is a big part of Bremont's appeal. The team are manufacturing around 12,000 watches a year. But reinvigorating a dying industry is not without its challenges.
Turn of the last century, we were making over half the world's watches. That gradually died out for a number of reasons, mostly due to 2 world wars. And so the biggest problem we have as a business is where do you recruit new talent to put watches together? Everyone here has gone through years of training to get to this stage. And you're dealing with pieces in this watch where the tolerances are minute. You're looking at 2 or 3 microns. The human hair is 50, 60 microns. And everything's got to fit beautifully. If it doesn't fit beautifully, it won't be working in the way it should be.
It's a lot more complex than you initially think, and then once you sit down and actually start doing it, you realise what we do here is really just like really complex Lego.
Making a watch is like an exam every time. You want to pass first time, you want everything to be perfect. It's a lot of concentration.
It certainly is, especially when you're assembling the escapement and balance spring. This is the tricky bit. The escapement regulates the speed at which the wheel train can turn. It allows power to escape, but only at set intervals.
This is your pallet fork, which is part of the escapement.
This pallet fork flicks back and forth allowing the escape wheel to turn. It's the movement of the pallet fork that creates the tick-tock of the watch. And like any mechanical device, it needs lubrication.
Just put a tiniest bit of oil on the surface of the stone.
It may not seem important, but without this tiny bit of oil, the watch wouldn't function as intended. The next component is the balance spring.
The fiddliest part is the spring. I think most watchmakers will agree with that.
This oscillates back and forward at a set rate, 28,800 beats per hour to be precise. No matter how much energy is released through the wheel train, the balance spring ensures the watch ticks at a constant speed. Getting over 300 tiny components working harmoniously is one thing, but making sure they can survive the most hostile environments on Earth is another. Before Nick and Giles launch a new model, they test a prototype in the most extreme ways they can think of. With the slogan, "Tested beyond endurance," the boys need to make sure their watches are practically bulletproof.
Back sort of over 10 years ago, we had Ewan McGregor and Charlie Borman wearing the watches for 4 or 5 months on the long way down. You can imagine on a motorcycle just bang, bang, bang for 4 or 5 months. And we learned a huge amount from that. Bremont is a watch which is based on engineering. That's what really gets excitement going within this business. It's about making fairly robust watches. It's not producing a watch based on fashion.
Nick and Giles have collaborated with a number of companies like Jaguar and Boeing. But one of their best-known partnerships is with Martin Baker, a British company who've been supplying air forces with ejection seats for the last 60 years.
They came to us and said, look, you've got these incredible people ejecting from aircraft. We saved 7,500 lives today. We want to produce a watch which these guys can buy. But this watch has to go through the same testing as the seats themselves.
Bremont test all of their watches to the limit, but working with Martin Baker took things to another level. From vibration testing to ejection launches and altitude testing. One test was conducted simulating a helicopter crash at over 18 G, moving at 42 feet per second.
And this is the end result. This is pretty much as tough as a mechanical watch can get.
Stuart has almost finished assembling the Bremont Martin Baker watch. The main components have been carefully installed, and the day and date wheel go on. Then the dial and the hands, which prove just as fiddly as everything else. The final piece of the puzzle is the auto-wind mechanism.
This is your auto bridge. This is what keeps the watch wound up when it's on your wrist.
This works like a wind-up torch or radio, except you don't even have to wind it up. The natural movement of your wrist makes the counterweight spin, and whichever way it spins, it winds the spring inside the barrel. So, as long as you're moving your arm around, it'll never run out of juice. The two brothers have come a long way since they formed Bremont in 2002. The business grew by a massive 26% last year. They export 40% of their watches globally. Nick and Giles have exciting plans for the future. They're building a state-of-the-art facility in Henley to house the whole business under one roof.
Continual investment. It's this big, deep, dark hole you're pouring money in, but incredibly exciting. And that's why we want to be here in the future and build a lovely manufacturing business.
And I think if Giles and I can look back in 20 years' time and say, what was Bremont about? If Bremont have played a small part in the reinvigoration of watchmaking in this country, I think we'll be very happy men, I think.